compare and contrast with average rate of change. So you know the difference and know when to recognize the difference between the two. So if you do have a function on some interval, okay, you have to have an interval. The average value theorem allows you to calculate the average y value. Okay, so this would be calculate the average y value. Okay. Or you could also say it's the average height of the function. So in this case, you're going to get an average y value probably somewhere in here. It's just going to spit a number out. It's going to be the average. Okay. It's most useful in contextual problems where you need to say, you're given a function and you need to find the average number of apples in the basket or something of that nature. Okay, so good. Just find the average height there. So the calculation, let's call this function. Okay, it's a theorem. It's a way of conditions on this.
Yes.
What would the condition for this be?
That has to be differential and continuous. Maybe not differential, but definitely continuous.
Definitely continuous. It's an integral, so you have to have continuity. What would it need to be differentiable?
No, I think it would.
We're not doing derivatives, so you
Yeah.
don't have to worry about it. Okay, so
And that has to be on an interval.
F must be continuous on AB. Okay. Good. If you're interested in how that is proven correct and true, there is a proof in your book. Have fun. Okay. So let's do a straight up math problem. So jump right into a trig function. Average value of sine x from 0 to pi. What's the setup?
1 over pi of the integral from 0 to pi of sine x.
Is that too easy for you?
What? No, I really had to think about what pi minus 0 was, no lie.
And a derivative of cosine is?
What? The derivative of sine is negative cosine.
Right. That's what I said.
That's not anyway.
Right? Agree with me or fail? Say.
That's the most subtle way to say that.
Correct me if I'm wrong.
You would have just said agree with you with that, so.
You caught that, dang it. This is such an inclusive classroom. Okay, you good with that? Straight calculation. Okay. A lot of times these will be done with, in conjunction with, say, a trapezoidal sum or a midpoint sum or a Riemann sum of some kind, right? So I've put a problem in there in your packet.
That's pretty.
Yeah, it's a little bit small. I can read it. Why can't you? Okay, I probably have most of these memorized by now. So hot water is dripping through a coffee maker, filling a large cup with coffee.
Not whales slapping.
There are no hot wheels dribbling through a coffee maker, okay. The amount of coffee in the cup at time t from 0 to 6 is given by a differentiable function c, where t is measured in minutes. Selected values of c of t measured in ounces are given in the table above. Right? This part c, use the midpoint sum of 3 subintervals of equal length indicated by the data in the table to approximate the value of. Okay, go. Since you know how to do that, ready, set, go. And then we'll explain the meaning and context of the problem. That's where the average value theorem really gets its value.
Right there.
Okay, so midpoint sum, 3 subintervals, 37. Think too hard.
Oh, gee, I just put the 2 on the outside and added one.
Would it be 2 on the outside or a 3 on the outside?
2. Year to 2, 2 to 4, 4 to 6.
It's the size of the subintervals, not how many there are.
Yeah, start counting zeros. Do you do that one thing?
What?
Counting zeros after
That's what I
programming?
was doing, yeah.
You know, zeros.
0, 1, 2, 3.
Yeah, because there's 3 boxes. Yeah, I totally
You don't divide by 6.
Okay, here's your midpoint sum.
Midpoint.
Okay.
So they're showing you the average value here.
So that would be a point. Okay, don't have to worry about going any farther. If you do this, you just earn 2 points. Okay.
Is this like have some?
What?
What did it say?
Midpoint sum, NP sum.
That's not.
It's Arthur's script. It's a new font I'm developing. All right, so be careful. Please do not do this. You are now incorrect. You just lost a point. Why?
Because the midpoint sum isn't correct.
This is right. You still get this point. Why is this now the answer incorrect? Why is this not right?
Can you take out the 2?
No, you factor out the 2. It's because that's the average value, not the midpoint.
Oh.
Are those statements equivalent?
No.
They are not. Okay. If if you're gonna do this separate, a lot of people do it, and I've seen a lot of you do this separate, do not put an equal sign.
You do this really thing? And then you just drag it.
That's fine. There's your midpoint sum and there's your average value. You get it, right? Okay, so be careful with that equal sign because it means quite a bit in mathematics.
This isn't a free response. Can you just put the 1/6 outside of your original value?
Yeah, that's what I would do.
Okay.
Just put it up here and there we
Oh,
go.
Lord.
Using correct units, explain the meaning of 1/6, 0 to 6 C of t in the context of the problem. So, always start with your subject. Or is, doesn't matter. Okay, what is the contextual meaning?
The average value of ounces, right?
Average number of ounces
Flowing through the coffee. No, in the food.
of coffee. Where's the coffee?
In the cup.
In a cup.
From time 0 to 6.
Per minute.
What?
Is it right?
But it's not.
Is it per minute or
Wouldn't you
is that
lose-
correct?
You'd lose that, wouldn't you? Wouldn't it be the average amount, or the average number of ounces in the coffee cup at any given point between T0 and 6? Because you lose the per minute once you integrate.
Yeah. No.
What?
It's not a per minute function, so we shouldn't put that. The average value theorem deals with the function. It doesn't change your units. Okay, that's where a lot of people trip up. 'Cause you want to think it's an integral, so I need to go up a level in units. The average value theorem does not do that. The average value theorem sticks with what is there.
So you have 2 liters in a cup, you don't say you have 2 liters per minute in a cup. You have 2 liters in a cup.
Right? And that would be an average amount in a cup.
But then why would you say per minute?
You don't. That's why I erased it.
Doesn't that prove what you read?
Average number of ounces of coffee, that's the units.
Okay.
That's it. The average value theorem sticks with the units that you see.
Yeah. Okay. There's
Okay.
confusion for no reason.
Don't make it harder than it needs to be. Right? I dare you to put that on the AP test. In the cup.
I'll do it.
Okay.
Dodge.
And while we're supposed to be thinking about calculus, we're thinking about different ways to say things. Into cup.
I mean, it's not the
Well,
living
that
thing,
is
so-
calculus.
Okay, so pay attention.
It's not the living thing.
This problem is asking about the data that you're given. Okay, that's what we're analyzing, right? The next one does not. Okay, this is one that this is very easily mixed up with what you need to do.
Trinity runs back and forth on the east-west looking world between A's velocity measured in meters per minute is given by a differential function V A of t, where time t is measured in minutes. Selected values for VAT are given in the table above. Find average acceleration of the train over the envelope 2 is less than or equal to t less than or equal to 8. Yeah.
What do you do?
Slap it in the integral?
Do 1 over b minus a to the integral of...
No. Because you're given velocity and you want acceleration.
I see.
Darn.
So we have to do the derivative of VAT?
There's no
Yeah.
function to derive.
No, it's...
So you just do slope.
Yeah.
Oh.
So much easier. Right? You're given velocity, you ask for average acceleration. This is average rate of change. That's it. see the difference there?
Yeah.
Here you have different functions you're asked about.
120 over 8.
Here, we were asked about this function.
Over 2.
That's average value theorem.
Duh, that's so
Okay, this is average rate of change because we're on different levels. Right, so 2 to 8, right? So we get negative 120 minus 100 over 8 minus 2. That's it. Done. 3 point. No, stop.
Yeah.
I did.
Side stop. Okay, very nice. Okay, you see the difference though. Be very careful about that difference. Now, what if the problem says, what is the average velocity?
Then you do
0 to 12. And then it would say something like, using a left Riemann sum 1, 2, 3, 4 with 4 subgroups. Okay. Now that is asked about velocity, average velocity, or given velocity, right? This is the average value theorem. Okay? Be careful. Questions? Very nice. Okay.
one rosary.
Work time.
So first you throw my breakfast to the ground, and then you want to pierce my nose.
Okay, let's not reveal
My lord, stop it.
our. Let's not reveal our stupidity to the internet.
I think I gave up on
You
that.
should have thought of that before you started recording these.
You should have thought of that
You gave up
before
on
you
that one last
decided
year.
to agree to have us in class.
I remember there's some really funny joke from when we recorded last year.
Some
Jeff said
absolute
something
gem,
about
yeah.
that from laughter.
Yeah. About that.
Did you edit it out in the final version? Because you didn't
Do that, no. I don't do that kind of thing.
You act like archery.
Is that a 9 or a 4?
Hey, you're a niner in there.
What was I doing? Oh.
First you did.
Holy moly. No, 4 essays were right.
At the
Wow.
end of the month.
Do.
For what?
Right.
Scholarship.
I'll be kind.
Oh. Well, thank you.
Dude,
Thank
today
you.
Friday.
Tomorrow, you have a quiz Friday.
Oh,
Tomorrow I'll do cross-sectional volume. You'll get your project for this semester.
So is that all one equation?
Yeah, I'm not sleeping for this.
To earn a high grade, you have to have 2.
Because like I was thinking about what shapes I could make